And what's the big difference then? If it's so much easier to understand and comprehend, even for people without a lot of experience, as you mentioned, what are the big differences between a high performance HMI screen graphics and the more standard ones that we've seen for years and years now?
Yeah, I mean, so there's quite a few differences, and I know there's a lot of people that are pretty not to say against, but that are not that are hesitant to kind of go to the high performance HMI principles.
Mhm.
But they kind of like to stay with the more classic traditional representations. I mean, a lot of the classic ones, it's a literal visualization representation of the process, right? You're
Mhm.
seeing
Yeah.
exactly how it's laid out, and you get a lot of detail on the screens. A lot of information you have to kind of digest, and there's a lot of colors, a lot going on. It's because we want to represent the process the best way we possibly can.
Mhm.
Well, with high performance HMIs, it's really they look a lot more simplistic, right? And they're typically using grayscale rather than traditional graphics and bright colors. And conceptually, this operates under the idea of visually contrasting critical and non-critical states. So that way, when something goes wrong, a high performance HMI will quickly guide the user to the source of the problem. Just at a glance, for example, if we had a real grayscale screen, at a glance, if I saw red, that's going to signify that there's an issue, right? If there's red or orange or yellow, especially if there's not only color, but there's multiple like redundant coatings, if there's symbols and things that go along with that, helps us understand where those issues are really coming from. Plus, it's all about adding more context to the data. And that's really important, right? We want to be able to look at the screen and be able to understand the data that's being presented in the fastest way possible. And I always like to use the example, if you go to the doctor and you get, they do some, blood work on you, and you get the results back, and they just give you a bunch of numbers,
Mhm.
and numbers are just all the same color, numbers. How would you know without having to go look up each of those numbers? What's the normal range of that number? Am I
Mhm.
good? Am I bad? All that kind of
Yeah.
stuff, right? And so we want to be able to apply these principles to an HMI so that instead of just getting back numbers, I get back, for example, a range, and I can see an indication in the middle of that range. Hey, that I'm in the accepted range, or no, I'm outside of it, and now it's colorized. Uh-oh, that's a number that I should be looking out for, right? And so high performance HMIs do the same thing. If I have a set point out there, if there's, for example, I have a tank and there's a level on that tank, I want to know, is that within the right set point? Is it too high or too low? And if I have a little, what they call a moving analog indicator, I can quickly see if that's in the accepted range or not, just by seeing that it's inside of it, right? And if it's out, I get a color, some representation. So it's not only about providing, making it easier to understand what's going on, but providing that context, making it so that people don't have to do a lot of thinking, right? The human brain's really, really good at actually finding out all these like visually seeing these little like digesting that information. We want to be able to help it out. Let us do his job
Um,
really, really quickly.
So I like the examples you gave there with the lab report information from your doctor and such. This is kind of getting back to your point about the point highlighting the criticality of some information versus others. Would you say this is kind of part of an idea or a concept around HMI to make it not a screen that you're necessarily have to look at all the time and be focused on, but something that you can glance at periodically? And if there's anything trending out of the normative range, that it's going to show immediately. So is this to kind of open up the field of view for operators? Is that kind of the idea behind it, or is it from something else?
No, exactly. I mean, you look at it, a lot of our systems have a local display next to it, right? So we can kind
Mhm.
of go over to it and take a look at it. But you don't want to park somebody in front of that display all the time, watching it like
Mhm.
really intently. Okay, am I going to have problems? You want them to be able to do their job most effectively. And so the idea of having a screen that even if they're further back, they can look at it and get a sense if things are okay or if it's not, right? And if it's not, they can kind of go in and get a lot more detail about, going a little closer to see exactly what part of the process and really understand that a lot faster. So absolutely. And a lot of this kind of came from, I mean, you think about it, we started getting digital displays, right? And we had to then put our process on digital display. Before that, it was very much in a control room. You had lights and indicators and buttons and all the physical things, right? Now we have a digital display, and we said, hey, all right, engineers, your job now, let's go put your process on that digital display. And it's like, well, how do we do that the most effective? We didn't really give people a set of tools or guides on how to do that effectively. And that's really what high performance HMI is all about doing, is giving these tools and guides to help them display it in the best way possible. So yeah, absolutely. And you get to critical processes, a lot like if you look at in petrochemical, or if you're doing nuclear reactors and you're monitoring that, you're going to need these principles because there's just so much data and you got to make sense of that data very quickly.